Hey everyone, I'm just going to walk you through the first part of the correlation PowerPoint. And of course, if you have any questions about this, you can definitely contact me. I'm more than happy to answer any questions or concerns that you might have. Okay, so let's get started. A correlation is a statistic that expresses the strength and direction of the association between two variables. So basically, the important points here are that correlations tell you something about how two different variables are related to each other. And it tells you specifically how strong that relationship is and what direction that relationship is in. So I have some examples down here at the bottom. The first one says, does the incidence of depression vary with the amount of sunlight in a particular location? So the whole idea here is that being exposed to more sunlight should actually lead you to be less depressed. And on the flip side, if you're exposed to less sunlight, then you should be more depressed. If you're thinking about this in terms of the direction, this is a negative relationship, okay? Because as you go up on sunlight, you actually go down on depression, okay? Or you could think of it as you go up on depression, that would be associated with going down on sunlight, okay? So they don't match, therefore, that would be a negative relationship. The second example is, does exam performance vary with the amount of sleep obtained the night before? So obviously this presents the idea that if you get more sleep, then you should do better on your exams. And this would be a positive relationship. Okay, as sleep goes up, exam performance should go up. As sleep goes down, exam performance should go down. Those match. Therefore, we would consider it a positive relationship. This last one's just in here for fun, and it's a social psychology study that's been done before on, does perceived attractiveness vary with the number of hours before closing time in the bars? And the whole idea here is that obviously as the night goes on and closing time gets closer and closer, people might become more attractive to you for various reasons, lots of different reasons. But we would say, like, as closing time approaches, so as closing time gets closer and closer, it goes up, perceived attractiveness would also go up. So I would consider that a positive relationship there. Okay, so the value of the correlation tells you about the strength of the relationship between the two variables. A very important point here is that the correlation can only be somewhere from -1 to 1. So it's pretty much going to be a decimal point. Okay, so for example, 0.23, that's a correlation that would be possible. Or -0.56, that's a correlation that would be possible. If you find that your correlation is 0, okay, that actually means there's really no correlation between the two variables. They are not related. That's what we would say, they're not related. The closer your correlation gets to a 1, it could be the positive 1, it could be the negative 1, but the closer it gets to that, the stronger the relationship between the variables. So if you had a correlation that was like 0.90, that is a very strong positive correlation between the two variables. Okay, if you have a correlation that's like 0.15, that is a very weak correlation. Okay, so that's about the strength of the correlation. When you're talking about the direction of the correlation, you're just looking at the sign. So is it a positive 0.76 or is it a negative 0.76? So a positive correlation means that high values on the first variable go with high values on the second variable, and consequently low values go with low values. All right, so this is when we were talking about the amount of sleep that you get and your exam scores. So as sleep goes up, exam scores should go up, right? So high values on sleep go with high values on exam scores. The negative is when high values on the first variable go with low values on the second variable, and low values on the first variable go with high values on the second variable. So this is the sunlight and depression example. So high values on depression are associated with low values on sunlight, whereas low values on depression are associated with high values on sunlight. So they don't match, and it's a negative relationship. So when we're trying to talk about correlations, we typically can illustrate these in scatter plots, okay? So scatter plots are used to visually examine the relationship between two variables. You would draw your, I sort of have the steps here, okay? So to do a scatter plot, you would draw your horizontal and your vertical axes, usually about the same length. You would label one axis with the name of one variable and the other with the name of the other variable. You'd begin the values on each axis with a 0 and continue to your highest possible value. And for each individual subject or participant or person, you would find the intersection of their value on the two variables and mark it with a dot. So let me just say that steps 1 through 3 are probably pretty intuitive here. But step 4, people do struggle with this some, so I'm going to show you some examples just to make sure that you really understand how a scatter plot works. So here's our example. We have two variables, coffee and quiz scores. And so I've just sort of arbitrarily decided to put coffee on the x-axis and quiz scores is on the y-axis, but you could flip them, it wouldn't matter. Okay, so let's see. If we're talking about person A, they have a coffee score of a 1 and a quiz score of a 1. Okay, so the dot that is at the 1, 1 mark, that's person A. Okay, person B has a coffee score of a 2 and a quiz score of a 3. So if you look on the graph, you should be able to find person B's dot. Their coffee should be at a 2 and the quiz score part's at a 3. The point that I want you to really notice here is that each person is only getting one dot, okay? Their dot, the way that we find their dot is by using their scores for coffee and quiz score together. But they're only getting one dot, and that's where people mess up the most on the scatter plot is they try to go in and give people multiple dots, and it just does not work out that way. Okay, so each person only gets one dot here. Okay, the other thing about this is a positive relationship. So the more coffee you have, the higher your quiz scores. You can kind of see that here if you're looking at participant F. They had 7 coffees, I guess, and their quiz score was a 5, which is the highest possible value you could get here. Okay, let's look at the negative correlation. So I flipped it, so we're not talking about coffee anymore, we're talking about beer. And I would imagine that if you have more beer, your quiz score should go down. So this is a negative relationship. High scores on beer are associated with low scores on quizzes. Okay, so you should see that if you're looking at the scatter plot, you sort of see this downward trend here, and that's a negative correlation. That's what a negative correlation looks like. It has this downward slope. And again, you should be able to pick out each particular person and where their dot falls. So if I'm looking for person D, hopefully you would be able to find person D where their dot is here. So if you look at beer of 4 and quiz score of a 2, you should be able to locate person D. Okay. So scatter plots can vary a lot in terms of what they look like. So I have some examples here. The first thing that I have is just a perfect correlation, and this just never happens, okay? But the maximum positive correlation you can have is an R correlations are represented as R's, and it's an R of a 1, okay? Cannot be higher than that. And it would be, you would only find this if your scatter plot looked like this. So a perfect association between your two variables, okay? Never seen this ever. Down here, right underneath it, you'll see the same thing, but with the negative. So a negative correlation, you see that downward trend there, and it's a perfect relationship. A strong positive correlation would be pretty great. That's a correlation around 0.8. So this scatter plot looks really great to me. I would really feel confident that these two variables are probably significantly related because we have this strong correlation here. Right underneath the strong positive correlation, you can see the moderate negative correlation. Now you can already tell, I mean, the dots are spread out a little more, not as consistent, not as close to being on that straight line. Therefore, the correlation itself is lower. It's negative as well because you can see this slope going down, so this downward trend. And the dots are farther apart, so that makes it the strength less. So it's a 0.43 correlation here. Zero correlation. This is an R of a 0. R of 0. So this would mean that there's no relationship. So being high on X doesn't really tell you anything about where you'll be on Y. You could be high or low, who knows, because there's no relationship between the two. I like this last one because it's showing you like pretty much a perfect correlation, but with one person who doesn't quite fit the mold here, and they pull that correlation from a 1 down to a 0.71. Okay, so outliers can have a strong impact on our correlations. Okay. So we ultimately want to look at the correlation, okay? But the correlation is based on something called covariance. So covariance is just the extent to which two variables vary together. That's why it's called covariance. So they're co-varying, they're varying together, okay? And you can also think of it as the degree to which the values of one variable tend to be on the same or the opposite side of the mean as values of another variable. And what I mean by that is that if you're above average on extroversion, and let's say I think that there's a relationship between extroversion and the number of friends that you have, okay? So I think that people who are more extroverted should have more friends, okay? So if I'm hypothesizing that, then I would think that if you're above average on extroversion, that you should also be above average on the number of friends that you have, right? And I might think that if you're below average on extroversion, then you should be below average on the number of friends that you have, right? So that's what I mean by being on the same or opposite sides of the means. If it's a positive relationship, if you're expecting a positive correlation, then you would think that they would match. So being higher on extroversion should be associated with being higher on the number of friends you have. I would expect a positive correlation there. If we're talking about being extroverted and let's see, anxiety, or like, let's do like public speaking anxiety. Okay, so I would kind of expect that if you're more extroverted, you're like less likely to have a fear of public speaking. So that's a negative relationship. So it'd be like higher on extroversion, lower on public speaking fear, public speaking anxiety. So I would expect for you to fall on opposite sides of the mean. So if you're above average on extroversion, I would expect for you to be below average on fear of public speaking, okay? And vice versa. So if you're, let's say, low on extroversion, I would expect you to be, or let's say, instead of low on extroversion, say below average on extroversion, then I would expect you to be above average on fear of public speaking. Okay, so that's what I mean by the same or the opposite side of the mean. And in the next video, I'll pick up with the formulas and how this will play out.